Now in this video we will talk about outlier and inlier. So outlier refers to the older bed outside and the younger rock is surrounded by the older rocks. And inlier has the older bed inside and the older rock is surrounded by the younger rocks. How outlier is formed? They both are formed by produce folding, faulting, erosion or combination of all. Suppose this is a fault. This is Horst, this is Graben, A, B, C, B, A, C, B, A. Here C is the younger layer and A is the older layer. And there will be erosion of this layer. And now this will be formed like this. Finally, this will be formed like this. Sorry. This will be formed like this. Now the younger layer has come in the core and it is surrounded by older layers. This will be the outlier. Now inlier. Suppose this is the syncline fold. Syncline fold. This is the younger layer. This is the older layer. Older layer. Now there will be erosion of this layer. It was like this. And there will be erosion of this upper layer. Now it will be formed like this. And finally it will be formed like this. Now older has come in the core and younger are it is surrounded by the younger layers, so it will be now considered as inlier. Now recognition of unconformity in the field. First is the observation in the single outcrop. By observing the outcrops exposed along mountains, quarries, roads and rail cuttings, and presence of conglomerate. Presence of basal conglomerate at the base of sedimentary sequences. It contains clast derived from the underlying rocks. This conformity is recognized this. Suppose this is the deposition and here there will be erosion. So sediments will be derived from this, and now there will be a time gap. These rocks will undergo compaction, sedimentation, and this layer, younger layer, will be deposited. So there will be presence of conglomerate between these layers. Third is the abrupt truncation of the beds. If beds are suddenly truncated against other rock sequences, beds are not repeated across the discontinuity surface. This is the bed B. It is not extending further, and the C has come because of the erosion of this layer. An abrupt change in the edges of the rocks. First is the gap in the paleontological record. Suppose this is the layer. This is the older, this is the younger. If these rocks contain upper Triassic fossils and this rock contains lower Cretaceous fossil, then there will be unconformity because there is a very large time gap between them. Now gap in the stratigraphic record. Suppose this is the layer depositing. Now more layers should be deposited, but due to unconformity, the layers are not deposited at a time. There is a time gap. So there is local absence of distinctive strata, which is characterized by lithologic, paleontologic peculiarities, or both. An abrupt change in the metamorphic grades. difference in the grade of metamorphism underlying and overlying rocks. Suppose here we find gneiss, and here we find slate. So there is a change in metamorphic grade. This indicate high temperature and pressure metamorphic grade. This indicate initial metamorphism, low temperature and pressure. So there is a difference in the grade of metamorphism, difference in the intensity of deformation, difference in intensity of folding in both younger and older sets. Older formation will be more deformed. As we said, this is the older layers forming tectonic activity. There is upliftment, it is deformed. Now there will be erosion. There will be erosion of this layer. So this older layer is more deformed. Now younger are depositing. It is less deformed as compared to the older one. So there will be an unconformity. So thanks for watching.